I'm Anil Kumar, and in these set of videos we will learn how to sketch graph of a function given some conditions, especially when derivative of the function is given to us. Question before us is sketch a continuous graph that satisfies each set of conditions. F dash x, that means derivative of the function is less than 0 when x is not equal to minus 1, and value of the function f of minus 1 is 2. So that is the condition given to us. So first is, let us try to sketch what is given to us, and then from there we will try to sketch the graph of the function. Okay, so first condition which is given to us is that f dash x is always negative. Less than 0 means always negative, except for x equals to minus 1. Now since we are looking for a continuous graph, we'll assume this value to be at that this derivative is actually equal to 0 at minus 1. That is what it really means. And the only graph which I could make could be like a parabola which turns from minus 1, kind of like this. Do you see that? So if I draw this function, which for me is f dash x, now this particular point where it turns is also the x-intercept, right? So this is minus 1. So now this graph satisfies the condition that derivative of the function is less than 0. It is always less than 0 except at x equals to minus 1, where it is 0, right? Now the second condition given to us is the value of the function at minus 1 is 2. So we'll sketch now the function itself from the graph. So let us say this red color indicates the function. Value at minus 1 for the function is 2. So let us say this is the value 2. So what we are given here is value is 2. So you could draw many graphs which will satisfy this condition. So what it really means is all throughout the derivative is negative. That means tangent on the graph is going downwards, right? So the graph has to go downwards, but at this point it is kind of horizontal. Do you see? It is kind of horizontal, right? So like x cube graph, that when inverted will satisfy this condition. So what we can have is we can have a graph like this, like cubic function. Do you see that? Which kind of has a point of inflection here, kind of, which goes like this. So that kind of function will represent f of x. I hope that is absolutely clear. One more thing which you should understand is that always the relation, whenever we're talking about continuous, these are normally polynomial functions, then degree of f of x is 1 higher than degree of f dash x, right? So that also helps you to figure out what graph we are looking for. So what we find here is that f of x is continuous, right? And it is like cubic in nature, with point of inflection at minus 1, 2, right? So that is the point of inflection, and this graph represents the graph in question. I hope that helps. Thank you and all the best.